So we're going to be reviewing our exponent laws from grade 9, and then we'll be adding on a few new ones. So our first one here is our multiplication exponent law. And the first thing I always need to check is that I have the same bases. So because these both have a base of a, I know I can use my exponent laws. And then because I am multiplying my two terms, I'm going to add my exponents. So I keep my base and I add my exponents. So we try over here. I first notice that my bases are the same. So I'm going to keep my base and add my exponents. And you don't need to do that intermediate step there. It just makes things easy so everyone can see what I'm doing. And we can also do this when our base is a number. So if I look over here, both of my bases are -3. So I can keep my base and I add my exponents. That's our first rule. Our second rule is our division rule. So again, we need to make sure that we have the same base. So we need to have the same big number. And then when I'm dividing, I'm going to subtract my exponents. So the easiest way to remember that is that multiplication and division are opposites. So it makes sense that for multiplication I add, and then for division I do the opposite. So for our example here, we keep our base, and then we subtract our exponents. And similarly, we can also do this with numbers instead of a variable as our base. So we keep our base and we subtract our exponents. Next, we have our zero exponents. So when we have something to the power of 0, it always equals 1 no matter what. So z to the power of 0 is 1, -100 to the power of 0 is 1. And that works all the time. Even if you put it in your calculator, you'll notice that anything to the power of 0 will always give you the answer of 1. So our next rule is called our power of a power rule, and that's when I have this little power outside of the bracket. So I have two powers going on here. And when I have that situation, I'm going to multiply my exponents. So that's the next thing that's going to happen, is I'm going to multiply my exponents here. So again, we keep our base, and I'm going to multiply my exponents. And again, we can do that with a number as our base instead of just a variable. So I keep my base, and I multiply my exponents. And this one, for some reason it's not showing up on here, but it is our fraction rule. And when I have a fraction rule, this exponent here gets put onto my numerator and my denominator. So that will turn into a to the n over b to the n. And that's where that goes. So we're going to do a couple of examples here. If I have x over y all to the power of 2, that equals x to the power of 2, y to the power of 2. So that little exponent here just gets put on my numerator and then my denominator. And similarly, we can use this with numbers as well. And my exponent is going to go onto both the numerator and the denominator. So that is our recap of grade 9 power laws. And we did a little quick review of them at the beginning of the year. So there's loads of practice there too if you need a little bit of a refresher. But now we're going to move on to the grade 10 rules. And the first one is our negative exponents. So any base raised to a negative exponent is equal to the reciprocal, and we've saw that word before with our negative reciprocals, of the base raised to the same positive exponent. So anytime you write your final answer, it's important that all of your answers have positive exponents. If you have negative exponents in a final answer, you won't get full marks because that's technically improper form. So how we're going to change our negative exponents to a positive one is we look at our base first. This negative exponent here is basically telling me that this whole term is on the wrong side of a fraction. And that's where this reciprocal part comes in. So in order to make this positive, I need to take the reciprocal. So secretly under this a, we have a little 1 hanging out. So in order to make that a positive fraction, it needs to be on the other side of the fraction. So all I'm going to do is I'm going to flip the fraction. My a to the negative m goes on the bottom, but what happens is that m turns to a positive. So now I have all positive exponents. Similarly, down here, because I have a negative exponent on the bottom of a fraction, it's telling me it's on the wrong side of the fraction. So what that means is I have to move that whole a to the m to the other side of the fraction. And when I do that, move it to the other side, my m becomes positive. So all I did is I just switched my numerator and my denominator. But because it's just a 1 on the bottom, I can just write that as a to the m. So again, over here, I have this negative exponent. So that's telling me that this 2 to the negative 3 is on the wrong side of the fraction. So we have our little 1 hanging out. In order for this to have a positive exponent, it needs to be on the bottom of the fraction. It needs to switch to the other side. So I switch it to the other side, and then that exponent becomes positive. And finally, our last one here, we have a negative exponent down here on the bottom. So that's telling us that that 3 to the negative 3 is on the wrong side of the fraction. So what I'm going to do is I'm going to bring it up to the top and switch what side everything's on, and then I can just simplify that. Okay, that's our first new piece. The second one we're going to look at are the degrees of polynomials. So the degree is basically the sum of the variables. So this is the degree of a term, and it's the sum of all of my exponents. So for this one here, we have a secret little 1 here. So we have the degree of 1. So I look at all of my variables, I add up all of the exponents, and here I have 1. For a second one, I look at my exponents, I only have a 2 here, so my degree is 2. For the next one, I look at my variables, I'm going to add up my exponents, so we have a 2 and a 5, so my degree is 7, so I add them together. And then finally, I look at my last one, I look at my variables, I have a 2, I have a 1, and I have a 1. So my degree, if I add them all together, will give me 4. So basically, I look at a term and I add up all of the exponents on every single variable, and that is my degree. Now, using those degrees of terms, I can find the degree of a polynomial. And basically, this is going to be the highest degree of each term. So what you're going to do is you're going to look at each term, and you're going to look at the degree of each term. So this first one here, we have an exponent of 1, so the degree of that term is 1. And then the degree of this term here, we have a y to the power of 2, is going to be 2. So basically, the one that wins is our highest degree. So this whole polynomial has a degree of 2. Similarly over here, we're going to find the degree of each term. So this first term has an x squared, so that has a degree of 2. Our second term is a y squared, so that's a degree of 2. And then since they're both 2, that means the degree of the whole polynomial is 2. Finally, if I look at my last one, my degree of my first term is going to be 5 plus 2, so 7. Then my degree of my second term is just 6. So that means my total degree of the polynomial is 7. Okay, so we're going to be continuing on, and this part is grade 9 review. That's really, really important for this unit that we all feel very comfortable with this stuff. So what we're going to be doing is we're going to be adding and subtracting polynomials. In other words, we're going to be collecting like terms. So remember that like terms have to have the same variables raised to the same exponent. If there are multiple variables, like AB is the same as BC. AB is the same as BA. As long as they have the same letters raised to the same exponent, then they are like terms. So we'll look at this first one here. And we're going to start by identifying our like terms. So the first one we're going to find is anything that has an n squared. And I'm going to put those at the very front. So I'm just going to rearrange this where all my like terms are together. The next like term I'm looking at are my n's. So again, I'm just going to rearrange those. And finally, we have just our coefficients, the ones that don't have any variables. So I can add those at the end. And now the only ones we're going to simplify are the ones that have matching variables. Remember that when we're adding and subtracting, variables do not change. So I have 4n squareds plus 1n squared will be 5n squareds. 3n plus n will give me 4n, and then 1 plus 2 will give me 3. Next one here, we're going to do a very similar thing. We'll start by identifying our like terms. And remember that the sign to the left is the sign that goes along with it. So we'll start by writing out our 3x squared, and then we have a negative x squared. So that sign that's to the left is the one that goes along with it. Then we'll write out our x's, and finally our constants. And then I can collect those like terms. 3x squared minus x squared is just 2x squared. Negative 3x plus 7x is 4x. And then 1 minus 52 is going to be negative 51. So our next option, the next level of difficulty, is when I have something like this, and I have brackets going on. So in order to get rid of these brackets, I have to multiply whatever number is in front of the brackets. So we have a secret 1 that's hanging out here. So to get rid of those brackets, I'm going to multiply that 1 in. 1 times 3x is 3x. 1 times 2x squared is just 2x squared. And 1 times 1 is 1. And similarly, to get to the brackets, get rid of the brackets over here, I need to multiply in that negative 1. So negative 1 times 2x is negative 2x squared. Negative 1 times 2x is negative 2x. And then negative 1 times negative 1 is positive 1. And now I'm back to where I started in the other question. So I'm going to start by identifying all my x squareds, identifying all my x's, and finally all my constants. And now I'm going to rewrite them in order. You don't have to do this step if you don't need to, but it does help people visualize what's going on. And now I can collect my like terms. So 2x squared minus 2x is just 0. 3x minus 2x is x. And then 1 plus 1 is 2. So that's my final answer. For our last one here, we have to start by getting rid of the brackets. So we have to multiply in these numbers on the outside. And then we're going to identify all of our like terms. So we'll start with our x squareds. Then our x's. And finally, our constants. And then I can simplify them by putting it in the right order. And now I can collect those like terms. So 2x minus 4x is negative 2x. Negative 12x plus 12x is 0. And then 4 minus 32 is negative 36. So hopefully that's coming back from grade 9. The next thing we're going to do is we're going to up the difficulty a little more, and we're going to practice multiplying and dividing some polynomials. So this is also a review from grade 9, but these are definitely a little more challenging. So for our first one here, we always start by looking at the constants. So if there's a number that doesn't have an exponent on it, we just treat those just like normal. So here we have 3 over 6. Those are our constants. So all I'm going to do is I think of how I could divide 3 over 6. So that's just going to be 1/2. And now I look at my exponents. So the first thing I want to make sure is that they have the same base. So I have a squared and a. And then I think when I'm dividing, what do? You can always reference the top of the sheet as well. When I'm dividing, I keep my base and I subtract my exponents. So 2 minus 1 is just 1. And we can also write this as a over 2. Those are both the exact same thing. Our next one here, we look at our coefficients first. So these big numbers that don't have any exponents or variables. And we have 3 and 4, and we're multiplying. So we can just multiply those first. 3 times 4 is 12. And then we look at our variables. So because we have the same base, we're going to add our exponents. So 2 plus 7 is going to give me 9, and that's our final answer. Our next one down here, we're going to simplify our numerator and then our denominator. So our first step, we look at our coefficients, so 2 and 8, and we multiply those first. So 2 times 8 is going to be 16. And now I'm going to multiply my variables. So I have the same base with my a's, and I'm multiplying, so I'm going to add my exponents. So 2 plus 1 is 3. And then I look at my b's. So I have 3 and 2. So I keep my base and I add my exponents. I haven't done anything with the denominator, so we'll just keep it. And now we're going to look at our coefficients again. So 16 and 4, and we're dividing. So that will give us 16 divided by 4 is 4. And now I look at my a's. So I have a to the power of 3 divided by a to the power of 1. So I subtract my exponents, so I'll have a to the power of 2. And similarly with my b, I have b to the 5 divided by b to the 3. So I subtract my exponents, and I'll have b squared. Our last one here, we start by looking at our coefficients and we're multiplying. So we start by multiplying those. 2 times negative 3 will give us negative 6. Then I have a squared multiplied by a, so I'm multiplying, so I'm going to add them. And then for my b's, I have b multiplied by b cubed, so I'm going to add my exponents and get b4. So our last step is to put all of this together. So similarly to above, when I have these numbers outside of the brackets, I need to multiply them in. And this is where our exponent rules come in. So I have 2x multiplied by 2x squared. So I keep my base on my x's and I add my exponents. Same thing over here. 2 times negative 6 will give me negative 12. And I keep my base and I add my exponents. And same with my last one over here. 2 times negative 2 is negative 4. And there's only one x, so that comes along with it. And for my next one, negative 4x squared times 8. So I look at my coefficients first. And then my variables, because there's no other variable, we just keep that x squared. Negative 4x squared times negative 3x. Start with my coefficients. So negative 4 times negative 3 is going to give me positive 12. And then I look at my variables. So I keep my base and I add my exponents. And finally, our last one, negative 4x squared times x squared. And then we keep our base and we add our exponents. So the next thing we want to do is we want to find some like terms. So I'm going to start with my biggest one, x to the 4. And then I'll look for my x to the power of 2's. Then my x to the power of 3's. And finally, my plain x's here. So now what I'm going to do is I'm going to write them in order from largest to smallest. And now I can collect those like terms. So we only have one x to the 4, so it just hangs out. Then we have 2x cubed plus 12x cubed plus 14. And then this will give me negative 44x squared minus 4x. And then I look at all my variables, and because there's none that are the same, I know I'm done. So we'll try the other one. Okay, so the first thing I'm going to do is I'm going to start over here and I'm going to address this over here. So we're going to start by using that fraction rule. And remember with our fraction rule that that exponent goes on our numerator and our denominator. So we'll have z squared all over x squared. And now we can start multiplying in these numbers here. So x times z squared will give us xz squared minus 6xy plus 2x squared. When you have multiple variables in a term, it's in your best interest to keep them in alphabetical order. It just helps you to see like terms. And then we'll multiply in this 4x squared. And then we'll multiply it into the fraction over here. So we'll have 4x squared z squared all over x squared. And before we do anything else, let's simplify that fraction term over there. So everything else will just stay the same for one more round. And 4 for my coefficient. There's nothing on the bottom, so it's just going to stay as a 4. X squared divided by x squared. We're going to keep our base and subtract our exponent, so 2 minus 2 gives us 0, so that just turns to 1. And then we have our little z squared left. And now I'm going to go through, and I'm going to look for some like terms. The only like terms are these guys right here. So we have 2x squared plus 32x squared. And now, in order to keep it all in the correct order, we're going to put everything with just x's at the front. And then we want to keep everything alphabetical. So next thing will be our xy's, then our xz, then just our z's. And I can simplify these two here, and then we're done.